If there's one thing Elon Musk knows how to do, it is to challenge the limits of what seems possible. And now, he is about to rewrite the rules of the game once again. Tesla has just announced a breakthrough that could forever change the future of electric cars: solid-state batteries. More range, almost instant charging, and durability that could leave any combustion engine in the dust. But what does this really mean? Are we on the verge of a revolution that will make lithium-ion batteries obsolete? The promise of solid-state batteries is no small feat. Imagine a Tesla that drives over 1,500 kilometers on a single charge, without needing massive batteries taking up the entire car floor. It sounds like science fiction, but this is exactly what Musk is bringing to the table. And the best part? Charging time, which is currently one of the biggest barriers for many drivers, could be reduced to just a few minutes. This means that stopping to recharge an electric car could become as quick as filling up a gas tank. And doesn't stop there. Beyond speed and range, this new technology promises insane durability. Current batteries start losing efficiency after a few years, but solid-state batteries could last over 10,000 charge cycles. In practical terms, this means a Tesla could run for decades without needing a battery replacement. This factor alone could put an end to any argument against electric cars, especially for those who still doubt their durability and maintenance costs. But the impact of this technology goes far beyond the average user. Think about competing automakers. For years, industry giants have tried to keep up with Tesla, but now Musk may be about to take a leap so big that it leaves everyone else behind. If Tesla becomes the first to mass-produce solid-state batteries, its dominance in the electric vehicle market could become absolute. Companies that fail to keep up with this evolution might simply disappear. Now, here's a detail that few are noticing. This revolution won't just affect electric cars. Solid-state batteries could also transform the way we store energy. This means that, beyond vehicles, this technology could impact everything from smartphones and laptops to renewable energy power plants. A home equipped with solar panels and solid-state batteries could store energy for much longer, becoming almost entirely independent from the power grid. The most impressive part? Elon Musk already has everything planned out. Tesla's gigafactories were designed to quickly adapt to new battery technologies. This means that as soon as solid-state battery production is ready, Tesla can start integrating this innovation into its vehicles without wasting any time. And if there's one thing Musk doesn't like, it's waiting. The plan is simple. Make this revolution a reality as quickly as possible before the competition even understands what's happening. Tesla never plays to tie. While many automakers are still trying to optimize their lithium-ion batteries, Elon Musk is already aiming for the next big leap, the definitive transition to solid-state batteries. But this race isn't a shot in the dark. The company has invested billions of dollars in research and development, ensuring it stays several steps ahead of the competition. And as always, Musk isn't doing it alone. He's acquiring the best talent and the best technology available on the market. One of Tesla's most strategic moves was acquiring Maxwell Technologies, a company specializing in dry electrotechnology. This was a crucial step to reduce production costs and improve battery efficiency. But it didn't stop there. Tesla also acquired Cellin, a company focused on lithium-metal batteries. These acquisitions are not just about expanding its portfolio, but ensuring that Tesla has full control over the development of next-generation batteries. And the breakthroughs are already showing. In January 2025, Tesla filed an innovative patent for a new lithium iron phosphate (LFP) battery manufacturing process, which promises to improve energy density and efficiency. Just weeks later, another patent was announced, a lithium carbon energy storage device that could further accelerate the transition to the new generation of batteries. Musk isn't just betting on a single solution. He's diversifying possibilities to ensure Tesla always has the best technology available. The importance of these patents goes beyond what it seems. They show that Tesla is not just working to create more powerful batteries, but also to manufacture them in a cheaper and more sustainable way. Mass-producing solid-state batteries is one of the biggest challenges in the industry today, and whoever masters this process first will have an advantage almost impossible for competitors to catch up with. Tesla has already proven that it knows how to turn a promising technology into an accessible product. It was like that with electric cars, and now the same could happen with solid-state batteries. But Tesla isn't the only one in this race. Companies like Toyota, Volkswagen, and Samsung are also pouring billions of dollars into developing these batteries. The difference is that while competitors are still in the early stages of research, Tesla is already advancing the integration of these technologies into its production line. That is the company's secret, not just innovating, but doing it with speed and scale. By the time the competition wakes up to this new reality, Tesla might already be selling cars equipped with a new battery. The pressure to advance this technology doesn't just come from the automotive market. Increasingly strict environmental regulations are pushing automakers toward cleaner and more efficient solutions. The US government, the European Union, and even China are imposing ambitious targets for reducing emissions, making full electrification of vehicles just a matter of time. In this scenario, solid-state batteries emerge as the ideal solution to accelerate this transition. There's no point in having the world's most advanced battery if there's no efficient way to recharge it. And in that regard, Tesla is already light years ahead. The company isn't just revolutionizing battery technology, but also ensuring that its cars always have a place to recharge, wherever they are. Since launching its first superchargers over a decade ago, Tesla has been expanding its global network, making it the largest and most efficient in the world. And now, with the arrival of new batteries, this infrastructure is becoming even more crucial. The growth of the supercharger network has been impressive. In October 2024, Tesla reached the milestone of 60,000 charging stations worldwide. No other automaker even comes close to that number. But the company isn't satisfied with just quantity. The next major upgrade, set for 2025, will introduce fourth-generation superchargers capable of delivering up to 500 kilowatts of power. For those unfamiliar with these numbers, this means that a Tesla could almost fully charge in minutes instead of hours. And that's not all. Tesla is also making its network more accessible to other electric vehicles. One of the biggest barriers to EV adoption has always been the lack of standardization in charging stations. But now, the company is implementing solutions so that cars from other brands can use its superchargers, including longer cables and adjustments to accommodate vehicles of different sizes. With this, Tesla is not just helping its own customers, but also accelerating the adoption of EVs as a whole. This infrastructure expansion isn't happening randomly. Tesla has a well-defined strategy for placing its superchargers in the most strategic locations possible. Each new station is planned to cover long-distance routes and high-demand areas, ensuring that drivers can travel without the fear of running out of battery. Charging corridors are being extended, and new stations are appearing in key locations across North America, Europe, and Asia. The impact of this expansion goes beyond convenience. One of the biggest challenges for electric vehicles has always been range anxiety, that constant worry about where the next charging station will be. But Tesla is eliminating that problem. Soon, finding a supercharger will be as easy as finding a gas station. And with the advancement of solid-state batteries, which drastically reduce charging times, the concept of waiting to charge could become a thing of the past. Beyond installing new stations, Tesla is investing heavily in upgrading existing ones. By modernizing equipment, wait times will be reduced and the network's overall efficiency will be enhanced. The new chargers, faster and smarter, can distribute energy more efficiently, ensuring that all connected vehicles receive the best possible power. This prevents long queues and improves the driver experience, allowing them to spend less time parked and more time on the road. If there's one thing that can completely change the game for electric cars, it's solid-state batteries. This concept isn't new, but now it finally seems ready to become a reality. The big difference compared to traditional lithium-ion batteries is in the name, solid-state. Instead of using a liquid electrolyte to conduct energy between the poles, these new batteries use a solid material, bringing a series of advantages that could transform the automotive sector. The first major advantage is energy density. Lithium-ion batteries have evolved significantly over the years, but they still have a capacity limit. Solid-state batteries, on the other hand, can store up to 3.5 times more energy in the same space. This means that an electric car equipped with this technology could drive over 1,500 kilometers on a single charge, something unimaginable by today's standards. With that kind of range, the idea of stopping to recharge a car in the middle of a trip could become a thing of the past. But it's not just the range that's impressive. Charging time is also undergoing a revolution. Today, even the world's fastest chargers take at least 30 minutes to provide a decent charge for a lithium-ion battery. But some solid-state battery prototypes, like those developed by QuantumScape, have already demonstrated the ability to charge 80% of the battery in under 5 minutes. This means an electric car could be recharged in the time it takes to grab a coffee, making the experience much more like refueling a gasoline car. Another major issue that solid-state batteries solve is durability. Current lithium-ion batteries begin to lose efficiency after 1,500 to 2,000 charge cycles. This is a problem for people who want to keep their car for many years without worrying about battery replacement. Solid-state batteries, on the other hand, can exceed 10,000 cycles without significant performance loss. This means decades of use without concerns, something that could completely change the perceived value of electric vehicles in the market. And there's more. One of the biggest problems with current batteries is the risk of overheating and fires. This happens because the liquid electrolyte in lithium-ion batteries is flammable, potentially causing short circuits that lead to spontaneous fires. Solid-state batteries eliminate this risk by using non-flammable materials, making electric cars even safer. This change could be crucial to convincing even the most skeptical drivers that EVs are the most reliable choice. Additionally, sustainability plays an even bigger role. Lithium-ion batteries depend on materials like cobalt and nickel, whose extraction has massive environmental impacts. Solid-state batteries use fewer of these elements, reducing the need for aggressive mining. This not only lowers production costs in the long run, but also aligns electric vehicles even more with the global sustainability agenda, one of Tesla's core values. If solid-state batteries truly deliver on their promises, the automotive industry, as we know, it could be running out of time. The transition to this technology isn't just a technical advancement, but a game changer that could make electric vehicles more affordable, efficient, and dominant in the market. And who will feel it first? Consumers. With a new generation of batteries, EV prices could plummet, finally making them cheaper than combustion cars. Today, one of the biggest costs of an electric vehicle is the battery. Lithium-ion batteries are still expensive to produce, accounting for up to 40% of the total cost of the car. With the introduction of solid-state batteries, this scenario could change dramatically. Experts estimate that the cost per kilowatt-hour could drop to less than $80 by 2030. This means EV prices could fall so much that, for the first time, buying an electric car will be cheaper than buying a gasoline-powered one. And when consumers save money, adoption grows exponentially. Beyond price, the experience of driving an electric car will become much more convenient. The fear of running out of battery in the middle of a trip is still a major concern for many people, but with a range exceeding 1,500 kilometers per charge, that problem simply disappears. Add to that a charging time of under 10 minutes, and electric cars could finally surpass combustion vehicles in every aspect. Resistance to change starts to fade when the new option is clearly better in every way. And that's not all. The used car market could also go through a revolution. Today, one of the biggest concerns when buying a used EV is battery condition. With lithium-ion batteries, after a few years, range begins to decline, which quickly devalues the car. But with solid-state batteries, which can last 10 times longer without noticeable degradation, an electric car could retain its value for much longer. This completely changes the game for both buyers and sellers. In the automotive sector, this transformation could be a disaster for manufacturers that fail to adapt quickly. Traditional automakers, still trying to balance combustion and electrification, could be crushed by the speed of this innovation. Companies like Tesla, which were born fully electric, will have a massive advantage. With technology that reduces costs, increases efficiency, and virtually eliminates maintenance, combustion engines could be pushed into obsolescence faster than anyone imagined. The race for solid-state batteries is far from a peaceful competition. Automakers and tech companies are investing billions to dominate this innovation, and whoever gets there first could gain a massive advantage over competitors. Tesla, as always, is playing to win, but that doesn't mean the battle will be easy. Companies like Toyota, Volkswagen, Samsung, and LG Energy Solution are also eyeing this prize, and each of them has powerful strategies in play. Toyota, for instance, is one of the most aggressive players in this race. The Japanese automaker has already accumulated over 1,300 patents related to solid-state batteries, making it the global leader in intellectual property on the subject. The company promises to launch its first vehicles with this technology by the end of the decade, and if it delivers, it could pose one of the biggest threats to Tesla's dominance. But there's a problem. So far, Toyota has been slow in adopting fully electric vehicles, which could give Tesla enough time to solidify its leadership before the Japanese automaker truly enters the game. Another major competitor is Volkswagen, which is betting heavily on QuantumScape, a startup focused on solid-state batteries. The company has already demonstrated significant advances, managing to produce battery cells with ultra-fast charging capability and high energy density. If QuantumScape can scale its technology to mass production, Volkswagen could become one of the first traditional automakers to offer this technology in its vehicles. But that's still a big if. Tesla, on the other hand, already has the entire infrastructure ready to quickly implement any innovation that emerges. The tech giants are also in the race. Samsung and LG Energy Solution are not only focused on electric vehicles, but also on using solid-state batteries for electronics and energy storage. Both have already developed promising prototypes, with Samsung claiming its technology can provide over 800 kilometers of range on a single charge. The problem for these companies is that, unlike Tesla, they don't manufacture vehicles. This means they will need to sell their batteries to other automakers, which could delay their widespread adoption. While the competition scrambles to develop their own solutions, Tesla remains one step ahead. Unlike other companies that still rely on external suppliers for their batteries, Tesla has a closed ecosystem. Its gigafactories were designed to quickly adapt to new manufacturing processes, meaning that as soon as this technology is ready for mass production, the company can scale up rapidly without relying on third parties. This is the kind of advantage that could be the difference between leading the market or falling behind. The solid-state battery revolution won't stop at electric cars. the impact of this technology could be much greater, reaching industries far beyond the automotive sector. If today's lithium-ion batteries already power a range of devices and energy solutions, imagine what a denser, more durable, and safer battery could do. Elon Musk knows this better than anyone, and Tesla is already eyeing industries that could be completely transformed by this innovation. One of the most obvious applications is in the electronics sector. Smartphones, laptops, tablets, and even smartwatches could benefit from this technology. Who hasn't complained about their phone battery running out too quickly? With solid-state batteries, these devices could last for days or even weeks on a single charge. Additionally, the lifespan of these batteries could be so long that users wouldn't need to replace their devices due to battery degradation. This completely changes the market dynamics, making products more durable and sustainable. Another industry that could be completely revolutionized is renewable energy storage. Today, one of the biggest challenges for solar and wind energy is intermittency, meaning the sun doesn't always shine and the wind doesn't always blow. What happens to the excess energy generated during peak hours? Currently, the solution is large lithium-ion battery storage systems, but they have limitations. With solid-state batteries, energy storage capacity could increase dramatically, making renewable energy even more reliable and efficient. This could have a massive impact on the global transition to clean energy. Companies and governments worldwide are already investing heavily in renewable sources, but there is still a need for an efficient storage solution. Tesla, with its Powerwall and Megapack, already dominates this sector, and integrating solid-state batteries into these systems could make the company essential for any major sustainable energy project in the future. And it doesn't stop there. Another sector that could feel this impact is aviation. The dream of electric planes has been hindered by the limitations of current batteries, which are too heavy and don't provide enough energy for long flights. But with lighter batteries and higher energy density, this barrier could finally be broken. Companies like Tesla and SpaceX could explore new possibilities for air transportation, bringing a real alternative to combustion engines that have dominated the aviation industry for decades. The maritime industry also comes into play. Cargo ships, which are responsible for a significant portion of global pollution, still rely heavily on fossil fuels. Some companies are already testing electricity-powered ships, but once again, the limitation lies in the batteries. If solid-state technology is incorporated into this sector, the environmental impact of the shipping industry could be drastically reduced, making freight transport cleaner and more sustainable.